this video is going to help you look at the cube root of x. So just like when we did the square root of x, we want to pick really good values to plug in for x. I want to think about cube roots, well, or a negative cube. So I know 8 is 2 cubed, right? And 3 cubed is 27, but 27 is a little too big to fit on my graph, so I probably won't go that high. So let's go negative 8, negative 1, 0, 1, and 8. These are really good numbers to choose. I want you to stop for a second, think about why would I choose those numbers if I'm using a cube root function. Alright, if I plug in negative 8, let's see what we get. The cube root of negative 8, the y value is negative 2. Now some of you might be wondering, well, why isn't it imaginary? Now I'm asking myself when I say, well, what's the cube root of negative 8? I'm asking what times what times what gives me negative 8. Can I multiply 3 numbers that are exactly the same and get a negative 8? I can. Negative 2 times negative 2 times negative 2. I can get a negative number with an odd root. Okay, so we get negative 2. The cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. So this is our parent function. You can kind of see that there's a pattern, right? Alright, let's go ahead and plot these. So we've got negative, and that is the function y equals the cube root of x. So that's our parent function for the cube root of x. We're going to take it and we're going to do transformations just like we did on the square root of x. So remember, these are the numbers we want to kind of keep in mind. Some perfect cubes, and also we can do negative and positive when we're doing cube root. Alright, so right here we've got the cube root of x plus 2. So we want to think about, okay, well, is this operation taking me right and left, or is it taking me up or down? We have to decide where we're going to be applying that to. So we want to start again with our parent function. So what were the numbers? Negative 8, negative 1, 0, 1, 8. Negative 2, cube root of negative 1 is negative 1, cube root of 0. Alright, so we're starting here when we're looking at the cube root function. Now you might be asking, well, Miss McSorley, why didn't you just plug in negative 8 right there? So my strategy that I'm giving you is important to help you prepare for pre-calculus and any future math classes. To actually see all the transformations in the table, it's helpful to actually start with the parent, and then do each of the transformations and see which values it's affecting. So there's a master plan here. So we just kind of want to ignore this plus 2. We write our parent function, and then we decide, okay, well, what are we doing? So this plus 2 really is affecting which values, the x or the y? Since this is taking me right or left, and it's plus 2, we need to do the opposite and go minus 2. So we're going to go left 2. So I'm going to go ahead and write that. We're going left 2 units. So we're really going to subtract 2 from all of my x values. Now I need to put my hands in the air and decide, okay, right and left, which axis is that? Right and left is the x-axis. So I'm subtracting 2 from the x. So I'm going to take x minus 2. So right here, I'm going to make another column, and I'm going to say, okay, x minus 2. So I need to take negative 8 minus 2. Negative 10. Negative 1 minus 2. Negative 3. 0 minus 2. Negative 2. 1 minus 2, negative 1. And 8 minus 2 is 6. Alright, so these are my new x values, and these are my y values. My y values didn't change. I didn't shift vertically. I didn't go up or down. So I'm going to go ahead and plot these points, and we'll see what happened to our function. Negative 10, negative 2. 2, 4, 6, 8, 10. Negative 3, negative 1. Negative 2, 0. negative 1, 1, and 6, 2. 1, 2, 3, 4, 5, 6, 2. Alright, so let's go ahead and graph this. Alright, so that's our cube root function. If you notice, this right here used to be at the origin, but it got shifted 2 spaces to the left, just like we predicted when we saw this. So it's a horizontal shift and 2 spaces to the left, the opposite of this. Okay, you could also think about what could I plug in here to bring this back to 0, and you would want to plug in a negative 2. Alright, let's try another. So again, we got our negative 8, negative 1, 0, 1, 8, negative 2, 0, 1, 2. Alright, so we've got our parent function. In this case, this negative 5 is telling me I'm going to go down 5. And I need to consider, okay, well, if I'm going down, is that going to affect my x-axis or my y-axis? You're right, it's going to affect the y-axis. So we're going to take that and we're going to add, we're going to subtract 5. So we do exactly what it says. We're going down 5, we're going to subtract 5 from all the y values. So negative 2 minus 5, negative 1 minus 5, 0 minus 5, 1 minus 5, and 2 minus 5. So these are my new y values. Alright, so we've got our x, we've got our y, we could plot these values. I'm going to plot them and then, so that I'm not taking up time, I'm going to hit pause. Alright, I probably should have told you guys to hit pause and try graphing it and then check and see, but that's okay. Alright, so this would be the graph. Let's just double check. We have the cube root function and we went down 5. So I started right here at 0, 0, kind of was the spot right here, and it shifted only down 5. Right? Every point on that curve shifted down 5. So if I had my original function, let's do this. Duplicate. We'll change the color. My original function might have been that one. Right? Oh, there should be an arrow here. Here, let's make it correct. Alright, so my original function, every point on this shifted down. 1, 2, 3, 4, 5. Every point. 1, 2, 3, 4, 5. You could take any point and shift it down 5 and it will give you the new translated function. So this is the function y equals the cube root of x, and this is y equals the cube root of x minus 5. And that minus 5 is on the outside, right? Because it's a vertical shift. Alright? So we've got some more complicated ones. I'm actually going to ask you to decide what do we need to do first and what comes second and third. Really what's important, we need to consider PEMDAS and always multiply before we add or subtract. So I'm going to kind of make this go quick. What I'd like you to do is you decide what needs to go on in these boxes here. I want you to make a title here, here, and here, and then I want you to hit play again. So you're going to hit pause, identify what different operations are going to happen, and then hit play and see if you got it right. Okay, so go ahead and hit pause right now. Okay, so you should have hit play, and hopefully you already have these answers in here. You want to check them. So we need to multiply first, and this is affecting the y, right? That's a stretch or compress, or it's a stretch. So we're going to affect the y-axis, and so is this. I'm sorry, it's not a stretch. This is a vertical shift, which moves us up 3. So that affects our y-axis as well. But we need to do multiply before we divide. So we multiply times 3, then add 3. On the x-axis, we have a shift here, but it's the opposite. So not x minus 4, we're going to do x plus 4. So we're going to take all our x values and add 4 to them. So go ahead and hit pause again. In just a second, I'm going to have all these filled in. So I want you to take a second, try it, and then check and see if you got it right. Okay, so go ahead and hit pause. Alright. Alright, so these are the numbers you should have in those columns. We would then use these two values. This is our new x coordinates, and these are our new y coordinates. So we're going to plot these points. -4, -3, 3, 0, 4 goes with 3, 5, 6, and 12, 9. Again, I want you to hit pause, try graphing that, just make sure that yours looks just like mine. So I'm going to hit pause, you hit pause, try it, and then check it. Alright, so your graph should look like this. Now remember, this one looks a little different than the last two. I'm going to jump back so we can see what it looked like. Notice how tall this is, I guess you could say. And consider us like putting silly putty on that and picking up that picture and then stretching it 3 times as big, shifting it up 3 and right 4, right? Up 3 and right 4, and stretching it by a factor of 3. So instead of going over 1, up 1, and over 1, down 1, just like the parent function, it went over 1, up 3, because we stretched it by a factor of 3. So it should look like this. So I'm going to go ahead, ask you to try this, hit pause, and the answer will be when you hit play. So hit pause for a second. Alright, so this graph should look like this. Now notice, we need to do the multiplication first. This actually is -1, so we need to multiply that -1 times our y first. And that's a reflection over the x-axis. If you notice, this looks a little different than the ones we've done in the past, where the cube root function looks like this. Notice that this has been reflected. If we take a pole right here and draw a circle, right? So we reflect it over the x-axis, and this ends up coming up here. So it ends up looking like that. Alright, here's your one problem I want you guys to try. So this is a compression. You want to compress it and do this. So bring this into class with you on Monday, and you're going to turn it in kind of as a check that you watched the video. Alright, have a great weekend.